Dear teachers, when you do assessment in your class, you collect the data in different forms. You use that data not only to grade your learners, but many times you compare your learners with the learners of other class, or sometimes within your class, when you have the assessment data of different subjects, you try to find out a relationship between two subjects. How do you do that? For such kind of interpretation, you need a statistical technique that is known as correlation. So in this session, we are going to discuss what a correlation is, what are types of correlation, how you can calculate the correlation coefficient, and what are its uses. So let us start. What do you mean by correlation? A change in one variable, if appears to be accompanied by a change in any other variable, then two variables are said to be correlated, and their interrelationship or this intervariation is called correlation. So what a correlation is? Correlation is if change in one variable is being accompanied by change in any other variable. And this covariation means the change in one variable and change in another variable. This covariation is known as correlation. When we calculate the correlation, before that we should be clear that where we can use correlation and what actually correlation is. From the definition, you can draw first conclusion that correlation is a measure of relationship, which is basically a measure of simultaneous variation of variables described by an integer. And the data which we study under the correlation means when we calculate the correlation between the two variables, that data is known as bivariate data. So for calculating correlation, many times we do exercise on bivariate data. And when one of these variables increases or decreases, the other paired variable also changes in proportion and simultaneously. But that change is not always in the same direction. That change is not always at a similar speed. Maybe one variable is changing at a faster pace, another variable is changing at a lower pace. But direction may be same, means if variable is going up, the another variable is also going up. Vice versa is also possible, means one variable is going up and the other variable is going down, or one variable is going down, the another variable is going down equally. But you should be very clear in your mind that change in one variable is correlated with change in other variable. It doesn't mean that there is a cause and effect relationship between two variables. No, there is no cause and effect relationship in correlation. So the study or the interpretation which requires cause and effect relationship, we should not use correlation as a statistical technique, right? When we use correlation, we basically talk in terms of coefficient of correlation. So correlation is a property, means one variable is changing, another variable is changing. If it is changing along with the first variable, it is correlated with that variable. That may be positively correlated, that may be negatively correlated. We will discuss about all these types of correlation later on. But how much correlation is? What is the degree of correlation? So when we talk about the degree of correlation, when we talk about the score or a value which can reflect the label or degree of correlation, we are actually talking about coefficient of correlation. So what is coefficient of correlation? It is the degree of association or relationship between two variables. And the coefficient of correlation is generally symbolized either by r, small r, or by a Greek letter rho. The product movement correlation, which is a type of correlation, which is also known as Karl-Pearson correlation many times, this is represented by small r. There is one more popular type of correlation that is known as rank difference correlation or Spearman's correlation. So Spearman's rank difference correlation is symbolized by rho, which is not r. So there is a difference when we can use r and when we can use rho when we are talking about correlation coefficient. Let us move further and discuss what are various types of correlation. Correlation is basically categorized into three groups. The first type of classification is the direction of correlation. Means either it is in positive direction or it is in negative direction. So correlation may be either positive or negative. The second type of correlation is simple correlation, partial correlation, and multiple correlation. And the third classification of correlation is linear correlation or non-linear correlation. Let us discuss these terms in brief. But before discussing this, let me focus on two more terms. Sometimes between two variables there is no correlation. Means no one can interpret that change in one variable can cause a significant change in another variable. So when the situation is like this, that change in one variable cannot cause a change in another variable, we call it no correlation. If there is no relationship observed or established between two variables, that is, the change in one variable cannot establish the change of other variable in a definite pattern, in a defined pattern, in an observable pattern, then we call it that there is no correlation. There is no correlation means the variables which are under study are not correlated to each other. Another just opposite term is perfect correlation. What do you mean by perfect correlation? Means if the change in one variable brings similar change in other variable which is paired with the first variable, this is called perfect correlation, and the value of perfect correlation is 1. So when a change in a variable brings a constant change in another variable, there is no variability in the change in another variable score. So if there is no variability, it is constantly changing with the one variable. This is called perfect correlation. But both the situations are most idealistic. Generally, the variables which we study or which we analyze as a teacher, as a researcher, they are correlated with each other. And if they are correlated with each other, it is very difficult, or I can say it is only idealistic correlation, that the value can be 1. On the other hand, it is also almost impossible that the value is 0. These are two extremes. So if you see the degree of correlation, value of correlation coefficient in different studies, if you review the researches, if you see the numericals, if you see the studies, you will find the value is always between 0 and 1. That's why the value of correlation is, there is no chance that value of correlation can go above 1. So it is always 0.75, 0.63, 0.53, 0.24. Plus minus may be possible. But 1.2, the value of correlation, almost impossible. The value 0 is also impossible. The 1 is also almost impossible. Very rare case you may find. Otherwise, the value is always less than 1. Now we move towards the types of correlation. I was talking about the first category when I was classifying the correlation into positive correlation and negative correlation. So what do you mean by positive correlation? If both the paired variables under the study vary in the same direction with any change, then that correlation is known as positive correlation. A very famous example is height and weight of the children. Generally, the weight increases with the increase in height. As the age grows, so there is a correlation between age and height of the children. I am not talking about adult or I am not talking about human. because after a certain period of time, the height can be constant, weight can vary. So then height and weight are not correlated after a certain period of time. But when the child is growing, means from infancy, during the childhood, early childhood, later childhood, up to adolescence, before getting the adulthood or maturity, before getting the maturity, the weight increases with the increase in height. So these two variables are positively correlated variables. Another type of correlation is negative correlation. So what is negative correlation? When the two paired variables under study vary in opposite direction. A very famous example is from the market. You can take the supply and price. If a commodity is being supplied to the market in excess, the price goes down. If there is a shortage of some commodity in the market and more is the demand, the price goes up. You can see this example very easily when the price of some vegetables goes higher during the period when that vegetable is not being produced at a large scale. Similarly, when that vegetable is available at a larger scale, the price goes down because supply to the market is high. So one variable is getting up, supply is getting up, and cost is getting down. So such kind of correlation is known as negative correlation. So these are two important correlation. And remember, whenever you are talking about a correlation coefficient, you cannot talk about a correlation coefficient without its direction. Means the value of correlation will never be 0.79 between variable A and variable B. It will be either plus 0.79 or minus 0.79, because the accompanying plus or minus denotes the direction of correlation. So whenever we talk about correlation coefficient, we always talk about the value with symbol. So either the value is with plus symbol or the value is with minus symbol. Value is never without a symbol for a correlation coefficient. Another category of classification is simple correlation, multiple correlation, and partial correlation. What is simple correlation? Simple correlation is the correlation between two variables. Means when only two variables are under study, the variation in one variable bringing changes in the another variable, and when we calculate this is called simple correlation. What is multiple correlation? When more than two variables are correlated with each other. It may be 3 variables, it may be 4 variables, it may be 5 variables. So when we study 3 or more variables, we do not calculate a simple correlation, we go for multiple correlation, because now variables are 3 or more. Then what is partial correlation? Partial correlation is partial because if the variables are more than 2, means there may be 3 variable or there may be 4 variable. But what we do? We try to study the correlation between 2 variables at a time, and we try to see the influence of third variable on the change of correlation between 2 variables. So we do not calculate the correlation between all the 3 variables. We calculate the correlation between any 2 variables, and we see the effect of third variable on the change or on the degree of correlation between 2 variables. So that's why it is neither simple correlation nor multiple correlation. This is called partial correlation, right? Another type of classification for the correlation is linear correlation and non-linear correlation. What do you mean by linear correlation? Linear correlation means if the amount of change in one variable tends to bear a constant ratio to the amount of change in another variable. If change in one variable bringing a constant change in another variable, this is called linear correlation. Means either it is increasing linearly or it is decreasing linearly, but the change is always linear, right? The another possibility is curvilinear or non-linear correlation. What is curvilinear or non-linear correlation? If the amount of change in one variable does not bear a constant ratio with the amount of change in the another related variable. Means the another variable is changing, but it is not changing constantly. The variation is in some chunks. Sometimes it is, the variation is quite high. Sometimes the variation is quite low. Sometimes there is no variation for a certain point of time. So if there is no constant change in the variation, then this is called curvilinear correlation or non-linear correlation. It is not a linear correlation. So these are basically important types of correlation. So any correlation may be linear correlation, that same correlation may be positive or negative correlation, that may be either simple or multiple correlation. It doesn't mean that these three are three different dimensions. No, the correlation is same. These three are basically three types to look on that. If there are two variables changing linearly with each other, this is linear correlation. This is simple correlation. If the change is positive, this is also positive correlation. If the change is negative, this is a negative correlation. So one correlation can be positive or negative. Same correlation can be linear or curvilinear or non-linear. And same correlation may be simple, multiple or partial. Right? There are two very common methods to calculate the correlation which a teacher generally use in the schools. But it doesn't mean there are only two methods of correlation. There are various methods of correlation. During the research, researchers study and apply different types of correlation. But as a teacher, I suggest you to study and to practice only two types of correlation. The first type of correlation is Spearman's rank difference correlation, which is denoted by rho. What is this? Actually, it is used generally when the data is in ordinal scale. Ordinal scale means when you have the data of the students in an order, either in ascending order or in descending order. It is the correlation between the ranks assigned to the individuals between two characteristics. Let me give you one example. Suppose in your class there are 20 students and one teacher has conducted a test of mathematics, another teacher has conducted a test of science, or you have conducted two tests, one of mathematics and one of science. All 20 students get some score in mathematics, all 20 students will get some score in science. If you arrange the scores according to the ranks of the student, means the first student, if his score is 19 out of 50, what is his or her rank in the 20 students? So here we don't consider scores when we calculate correlation. In the formula we don't put scores. In formula we put their ranks. So we arrange the students in their ranks on the basis of scores obtained by the student, and then we apply a very simple formula, rho equal to 1 minus 6 sigma d square upon n under bracket n square minus 1. So what is D? D is difference of the rank. For example, student number 1, he has got 40 marks in science and his rank is first, and 32 marks in mathematics, his rank is fifth. So the difference between the rank will be 5 minus 1 equal to 4. So in this way, first we assign the ranks to each and every student in their subject, then we calculate the difference of their rank. That's why this method is known as rank difference method. Then we square their deviation and sum that deviation. And what is n? N is the number of students, means if there are 20 students, the n is 20. If there are 50 students, the n will be 50. Right? So this is a very simple formula which you can use while you are trying to calculate Spearman's rank difference correlation. Most of the teachers use it. Why? Because it is very easy to calculate. You do not require very high order of statistics or higher order of mathematical operations. You just require a knowledge of multiplication, square and division, plus and minus. If you have these skills with you, you can easily calculate the rank difference correlation. Another correlation is product movement correlation, which is also known as Karl-Pearson correlation and denoted by R. Actually, Karl-Pearson correlation we can calculate when the data is in either interval scale or ratio scale. If the data is in ordinal scale, we cannot apply the coefficient of correlation proposed by Karl-Pearson. There are three methods actually to calculate the Karl-Pearson correlation. The first method is deviation score method. In this method, we apply the formula Rxy equal to 1 minus sigma xy over n sx and sy. In this method, we basically calculate their deviation from mean and deviation from standard deviations, and on the basis of that, we apply this formula. But the popular method is the direct method, where you can calculate directly the Karl-Pearson correlation from the raw score of the individual. So the formula is R equal to n sigma xy minus sigma x into sigma y under root n sigma x square minus sigma x square into n sigma y square minus sigma y ka whole square. Here what is x and y? X and y are scores of the individual, and n is the total number of individuals. So here you require only the raw scores, and with the raw scores you apply certain calculations and you can use it. Third method to calculate Pearson coefficient of correlation is a standard score method or z-score method. For this method, first we calculate the mean of both the score sets, means x and y. Then we find the standard score of both sets, means we convert the raw score into standard scores. Then from both the standard deviation scores, we calculate the z-score or the standard scores. So first we need mean, then you need to calculate standard deviation. After calculating the mean and standard deviation, you convert every score into a standard score or z-score, and after that you apply a simple formula R equal to sigma zx into zy over n. So this is again a very simple formula, but why many times teachers avoid this method? Because they require to calculate first mean, then standard deviation, then this formula. So if you have the mean and standard deviation with you, you can apply this formula. If you don't have, you can apply the previous formula where you can use the raw scores. Now the question comes, if you calculate a correlation coefficient, whether by using a rank difference method or you are using a Karl-Pearson correlation method, you need to interpret that, because correlation as a value is not significant, it is not telling anything. So when we interpret, we follow a standard pattern. What that standard pattern is, as I told you, 1 is the perfect correlation. If it is plus, 1 positive perfect correlation. If it is minus, it is perfectly negatively correlated. But it is not possible. If the value is between 0.90 to 0.99, this is called very high correlation, or it can be positive, it can be negative. If the value is between 0.70 to 0.90, it is high correlation. It may be high positive or high negative. If the value is between 0.50 to 0.70, it is moderately positive or moderately negative. If the value is between 0.30 to 0.50, it is low positive or low negative. If the value is between 0.10 to 0.30, the value is very low positive or very low negative. If the value is between 0.00 to 0.10, it is markedly low, or you can say negligible correlation. It can be positive, it can be negative. So in this way, we can calculate the correlation coefficient and we can interpret the correlation coefficient. Now what is the use of correlation coefficient? In last, we should also discuss this. Generally, when we develop the assessment tools, we develop research tools, we develop assessment tools, and it is being asked to us, okay, you standardize the tool. A standard tool should be used. And when we standardize the tool, the one of the dimension of a standard tool is establishing its reliability. When we establish reliability, the reliability is basically correlation coefficient. We calculate most of the reliability coefficients in terms of correlation. Either the correlation between the scores in first administration and second administration, we call the test-retest reliability. Either parallel form method, so we score the first tool, then we score another parallel tool, and we again calculate the coefficient of correlation. So coefficient of correlation is basically used to determine the reliability of a tool. When we use the validity of the tool, when we determine the validity of the tool, especially the tool when we use scores for prediction, we calculate the correlation. I'm giving you one example of it. You have seen a test for admission in the medical or admission in the engineering. If the scores obtained by the students in the medical entrance exams are correlated by the scores obtained by the students after getting admission in the medical course of their first semester marks, then the correlation coefficient will determine the predictive validity of the medical entrance test or engineering entrance test. So we use these correlation to calculate the validity also. Then to study the individual differences. To study the individual differences, we use correlation coefficient to know that one group and the another group, is there any difference between the two groups, or on different variables both groups are varying at the same pace. For predicting one or more variables, we use a higher order of correlation coefficients. To qualify the relationship between two variables, if there are two variables in the study, are they correlated with each other or not? Whether they qualify to be correlated variable or covariates or not, we use correlation coefficient. So dear friends, correlation is very important statistics. You require it for various purposes in your classroom, in your study, in your professional development, being a teacher. My suggestion is that before choosing a particular type of correlation, please study what are the types of correlation, where you can use those correlation, what kind of data is required to what kind of correlation, and how you will interpret the scores. Only then you will be able to get a significant meaning of a correlation coefficient. Thank you for listening me, and I hope that this discussion will help you in developing a basic understanding of correlation. Thanks a lot.